Yeah. Hello. This is this is our EE371 Lab 6 final project, and my name is Max. My partner is Aditya Manoj, and this is our final project on presenting our game, which is Taiko no Tatsujin. And here's just like a brief overview of the game. So this is actually okay. So the image shows an actual from the actual screenshot from the gameplay, the game that we're going to play later. And this is basically like a rhythmic game in which we have to hit the notes on the screen at a certain beats per minute. And we know that when the note is hit at the correct timing or when it's hit inside the green hitbox region, the user will be rewarded with a point. And currently we have the point being capped up to from a score of 0 to 99. So it's basically like when this red box enters the screen region and we hit our key on the same time, it's gonna increment the point counter. Okay, so here's just a little of the main logic of our design. So yeah, we're using the provided VGA display to output the game UI, which is the image that you've seen previously. And we have some sort of memory or ROM that stores a frame of each of the animation in 16-bit values. So each frame of our numbers, we partition the region on the VGA display into 16 blocks going horizontally, and each bit represents a block on the screen. So as you see over here, there's block of 0001. So one will actually be our red block over here, while 0 represents a black box. And we also have a hitbox region detection through the two most significant bytes in our 16-bit numbers. So over here on the very right, or like on the very left of the bit, these two, when these two bits are 1 inside of our frame, and when key is pressed, we know we've entered in the region. And we'll increment the counter by 1. And here's just like a top level diagram. And as I said before, actually, all these RGB generation logic video driver VGA, they're all provided for us. And I'll say the main thing here is a Taiko game controller, which is a state machine which is like a state machine for our game setting logic. And we have a start ROM and end ROM that loads the start and the end image as the game starts and the game ends. And we also have a score counter that keeps incrementing the score. Also, the music ROM and the synchronizer are all part of our top level design. So I've already loaded the program, the game, and yeah, I'm just going to start the game. Okay, just wait it to program. Okay, as you see here, the score is at 0-0. Yeah, okay, so here's our starting UI of the game. That's being generated actually using the image converter Python script that's provided for us. And as we press key 2, the game is going to start. So yeah, as you see here, there are notes on the screen, and as I keep clicking, it's going to increment the score, and I don't click, nothing happens. So I have to click once these red boxes enter the screen. And the score is going to be capped to 99 for now, but in reality, you should have, okay, yeah. So game over because we have set the game to being run at a certain duration of like around 30 seconds. So once the game is over, we can, like the game over screen comes, and we can restart the game with key 0. So the game starts again at 0-0. And I think that's it for our demo, and thanks for watching.